Hello, welcome to ANS Solver. This is the eighth question of the paper. So now there are four sides on the spinner A, B, C, D. The spinner is supposed to be fair. That means fair basically means if there are four sides, each probability should be 1 upon 4. But Sonam suspects that the spinner is biased so that the probability of P that it will land on A is greater than 1 upon 4. So this is basically my rival claim. Okay, he spins the spinner 10 times and finds that it lands on A 6 times. So this is basically my test value. Test Sonam suspicion using a 1% significance level. So my first null hypothesis claim is that my probability is equal to 1 upon 4, which is basically 0.25. My alternative hypothesis is my claim that my probability is greater than 0.25. Now I have probability like this. I have my x, I have my test value. Okay, these are the steps which we follow. Now, what will be a sign in the middle? I told you it's a basic trick. If this is more than, this needs to be more than but equal to. Okay, it's a basic trick which you need to know. Basically, this means the probability of x equals to 6 plus the probability of x equals to 7 plus the probability of x equals to 8 plus the probability of x equals to 9 plus the probability of x equals to 10. So now what I can simply do is I know my binomial formula, which is basically NCR into the probability raised to R into 1 minus P raised to N minus R. Okay, recall from AS level. This is the formula. Okay, so now what I can do is I can write this as 10C6 into 0.25 raised to 6 into 0.75 raised to 4 plus 10C7 into 0.25 raised to 7 into 0.75 raised to 3 plus 10C8 into 0.25 raised to 8 into 0.25 raised to 10 minus 8, which is 2, plus 10C9 into 0.25 raised to 9, okay, into this is 0.75. My bad. Sorry, made a mistake. 0.75 raised to 1 plus 10C10 into 0.75 raised to 10, or I made another small error, not 0.75, 0.25 raised to 10 into 0.75 raised to 10 minus 10, which is 0. Now see, you can either write this full thing on the calci, or I can tell you a simpler method. What you can do is, on the calculator, okay, simply click on shift and the log button. Okay, when you click on basically the shift and the log button, you get something like this with the summation sign, okay, and a bracket here. So now what you need to do is basically, here if you see, you are calculating the summation from 6 to 10 inclusive. So in the lower limit write 6, in the upper limit write 10. And here you can simply write, your n is 10, Cx into the probability, which is 0.25 raised to x into 0.75 raised to 10. I'll just remove this bracket for now. 10 minus x. So just simply write this. Okay, x basically will take all the values from 6 to 10 inclusive, and to write an x, you can simply click on alpha and the closing bracket, the closing bracket sign, button, whatever. Okay, so when you do that, just type this in the calci. Okay, 0.75 raised to 10 minus x with 6 to 10. Okay, so when you do this and you click on equal to, okay, you get your answer basically as 0.0197, which is basically the final answer of the question. Okay, easy. But now what we need to do is we need to test this with a 1% significance level, which can be written as 0.01. Now I know my probability here is greater. That means there's no evidence of an increase or of the dice being biased. Increase or dice being biased. Okay, this is what I can write. Now, later Sonam carries out a similar test at the 1% significance level using another 10 spins of the spinner. Okay, calculate the probability of a type 1 error. So the probability of a type 1 error basically means when you reject your null hypothesis, okay, but your null hypothesis is true. Okay, that means basically the probability of the critical region, okay, basically the area of rejection you can call it, okay, is the probability of a type 1 error. So we saw when this was more than equal to, okay, when this was more than equal to, you can simply, you got a no rejection. But here, if I take the probability of x, okay, which is more than equal to 7, which is basically the probability of x equals to 7 plus the probability of x equals to 8 plus the probability of x equals to 9 plus the probability of x equals to 10. You can check whether you're getting a rejection here or no. So basically what you can do is, in simple terms, everything will be added except this. And if you have seen my part 1 here, instead of a 6 here, you can simply put a 7. Okay, just put a 7 on your calci. Okay, if you know this is basically the process of how I calculated in part 1, you can have a look at it. Okay, so now the value when I put 7 there, I get is basically 0.00351. Now I can compare this with 0.01, which is a significance level, and as you can see 0.01 is more. That means I can say rejection, okay, starts from x more than equal to 7. Got it? This is basically the area of rejection. Okay, so basically the probability of a type 1 error is 0.0351. So my final answer should be 0.00351. Now, assuming that the value of p is actually 3/5, calculate the probability of a type 2 error. The probability of a type 2 error is basically the probability of accepting your null hypothesis, but a null hypothesis being false. Okay, so now what you can simply do is, in the above part, I mentioned the critical region, which is x more than equal to 7. I know this is my critical region, but this is the area of rejection. So the area of acceptance will basically be x less than equal to 6. Agreed? This is the area of acceptance, I can say. The probability of acceptance. Okay. What I need to do is, because I'm accepting my null hypothesis, I need to calculate this. Okay. But using my probability as 3/5. So basically the probability of x less than equal to 6 can be written as 1 minus the probability of x more than equal to 7 okay, which I can basically write here. I know my probability now is 3 over 5. Okay, don't write it as 1 over 4. So this is 1 minus the probability of x equals to 7 plus the probability of x equals to 8 plus the probability of x equals to 9 plus the probability of x equals to 10. Now what I can simply do is I can basically write this as 1 minus, okay, make a big bracket because you will need it. Now I know my binomial formula is simply NCR into the probability raised to R into the Q, which is 1 minus P raised to N minus R. So I can simply now write this as, I know my N, which is the same. I can take my N basically as 10 because it was 3 10 times. So 10C7 into 3 over 5 raised to 7 into 1 minus 3 over 5 raised to 10 minus 7, which is 3, plus 10C8 into 3 over 5 raised to 8 into 1 minus 3 over 5 raised to 10 minus 8, which is 2, plus 10C9 into 3 over 5 raised to 9 into 1 minus 3 over 5 raised to 1, okay, plus 10C10 into 3 over 5 raised to 10 into 3 over 5 raised to 0. Now what I can simply do is, I can, this area here, this part, instead of doing it on the, writing the full thing on the calci, I can do a shortcut. So in the calci, what you simply do is, I've done this in part 1 also, but I'll repeat myself, no problem. I can click on shift, and after I click on shift, I can click on log, the button log. When I do that, I get something like the summation sign with a limit here, and a limit here. A bracket. If you see here, we are calculating the summation from basically 7 to 10. So here I can write 7, here I can write 10. Now in the bracket, I can simply write 10cx into the probability, which is 3 over 5 raised to x, into 1 minus 3 over 5 raised to 10 minus x. Got it? Now x basically will take all the values from 7 to 10 inclusive, and to write an x, you can simply click on alpha and the closing bracket sign. So just write this much, okay? So 3 over 5 raised to x, okay, into 1 minus 3 over 5 raised to 10 minus x, from basically 7 to 10. When I click that, I'll take a little bit of time, okay? So now when I do that, I get my answer as 0.3822. But now I need 1 minus of this value. So I'll do 1 minus 0.3822. So when I do that, I get my value basically as 0.617 or 0.618 to 3 significant figures.